Hi, everybody. How are you doing? This is the 10th International Framework for Environmental Protection lecture about atmospheric pollution. The spring has come, but it is still very cold in the morning. So, anyway, let's get started with this topic, atmospheric pollution. The keywords are atmosphere, air pollution, PM2.5. PM is for particulated matter. Sources of PM2.5 and health effects of PM2.5. And we also have another harmful substances, as for example, SOx and NOx. So let's see about that. This is the picture of the Earth's atmosphere. The atmosphere is very thin layer of air, and this is just like a blanket of air for the Earth. And this blanket surrounds our Earth. It's very thin compared to the gigantic size of the Earth. So we have to protect it, but we are doing harmful activity to that, polluting the atmosphere. So the atmosphere is a thin layer of gases that surrounds the Earth. It seals the planet and protects us from the vacuum of space. It protects us from electromagnetic radiation given off by the sun and small objects flying through the space, such as meteoroids. And we have so many different kinds of space radiation that are very harmful to our health. But this layer protects us from that harmful radiation. And here we have the layers of the atmosphere. And we are living in this layer, troposphere. And after 10 kilometers high, we have stratosphere and higher mesosphere, thermosphere, and exosphere, 700 kilometers. This is the height of the satellites. The spacecraft of the spaceship is around this height. And aurora is, we can see from the Earth, from the bottom of the Earth, but it is formed in this altitude. And here is the temperature of these layers. In troposphere, we have a range of temperature from minus 50 degrees centigrade until maybe 60 degrees centigrade. Yes. In the deserts, we have the temperature of 50 degrees centigrade, and the top is 60 degrees centigrade. So after this troposphere, it's stratosphere, and it will be more cold. And after the mesosphere of minus 85 degrees centigrade, we have the thermosphere that is very hot. So 1,500 degrees centigrade, and exosphere is higher than 2,000 degrees centigrade. In the troposphere, we have the aircraft flying, clouds. Mountain Everest is 7,000, almost 8,000 meters high. And the radio zone for the researchers flies until 50 kilometers, lower than 50 kilometers. And the aircraft, the international aircraft usually flies above 10,000 meters, 10 kilometers. So the winds, typhoon, hurricane, that kind of meteorologic occurrences is in this troposphere, happens in this height. So these are the principal layers. Here is the temperature, and here are the artificial man-made transport and also natural phenomenon. Meteors that we can see in this height between 50 kilometer to 80 kilometer. So today we are speaking on troposphere. What is happening here? It is directly reflecting to our lives. So now let's see about the atmospheric composition. We have nitrogen, N2, 78%. So when we inhale the atmosphere, we are inhaling 78% of nitrogen, and oxygen, 20.95% oxygen. And other elements are inhaled in our lung, as for example, water, 0 to 4%, argon, 0.93%, carbon dioxide, CO2, 0.0360%. But now this value is different, as you know, 0.0410%, because the concentration of CO2 in the atmosphere is increasing year by year. This is 20 years ago. Neon, rare gases as argon, neon. Neon is 0.0018%, helium 0.0005%, methane CH4 0.00017%, hydrogen 0.00005%, nitrous oxide, this N2O 0.00003%, ozone O3 0.00004%. So these asterisk, water, carbon dioxide, methane, nitrous oxide, ozone are variable gases. So these are the atmospheric composition. We cannot see, but the composition is scientifically known, and we can measure it. So before flue gas desulfurization was installed, the air polluting emissions from this power plant in New Mexico contained excessive amounts of sulfur dioxide. So as you know, sulfur dioxide is one of the very harmful gas that are expelled in the atmosphere. So nowadays, in the developed countries, every industry expelling this kind of gases has to put flue gas desulfurization. So if not, no license is allowed by the prefecture or the state or by the country. So that's why our atmosphere, for example, in Japan, we can inhale safely because of this flue gas desulfurization law. And air pollution is happening in many areas of the earth. And air pollution is contamination of the indoor or outdoor environment by any chemical, physical, or biological agent that modifies the natural characteristics of the atmosphere. And household combustion devices, motor vehicles, industrial facilities, and forest fires are common sources of air pollution. So now let's see about the types of air pollution: chemical, physical, and biological contamination. The largest environmental health risk, causing millions of deaths because of air pollution. The vulnerable groups are elderly, children, and chronic lung and heart disease. So here we can see the sources of the air pollution. We have dust. This is the sea spray, forest fires, agriculture, energy and industry supply, waste, household energy, transport, volcanoes. So we are surrounded by these kind of air polluting sources. This is the indoor pollution. For example, in the bathrooms of a house, we have mildew or cleaning chemicals. In the garage or in the basement, we have radon, solvents, carbon monoxide. And in the kitchen, we can have smoke, chemicals, carbon monoxide, depending on the cooking stoves. And in the yard, we have pollen and dust, pesticides. And inside the house, we also can have pet hairs. Here is missing R. Now, let's continue with the particulated matter PM2.5 that we have in the atmosphere. And PM2.5 is a complex mixture of extremely small particles and liquid droplets. And particle pollution is made up of a number of components, including acids, such as nitrates and sulfates, organic chemicals, metals, and soil or particles. This is the fine beach sand. This size is 90 microns in diameter. And this is the human hair with 50 to 70 microns in diameter. And PM2.5 is smaller than this. This, for example, PM2.5 is a combustion particles, organic compounds, metals, and so on. It's less than 2.5 microns in diameter. And this blue is PM10. that is also harmful to the lung. This is dust, pollen, mold, and so on. And this is less than 10 microns in diameter. So these materials are almost invisible to our eyes. Only with an electronic microscope we can see them. But they pollute the atmosphere. Now let's see about the sources of PM2.5. The point sources. We have point sources and non-point sources. For point sources, we have automobile exhaust, this, manufacturing site, smokestack, soot. And this is for the non-point sources, fugitive dust emission, or fires, or smoke. A volcanic eruption, bushfire also are non-point sources. And we also have the chemical makeup of particles. We have skin scale, hair, insect fragment, starch, actinomycete spores, fungal spores, pollen, wood particle. So they are all microscopic. Organic dust, asbestos, lead, diesel exhaust, crystalline silica, cadmium, may be any suspended solid, liquid, or biological organism. So we inhale them into the lung. That's the problem. Because it is so microscopic that the nose hair can't catch them. It goes through because it is so tiny. For example, in Japan, limits of PM 2.5. This is by the air law, clean air law. Daily limit is 35 microgram per cubic meter per day. This value for yearly, the limit is 15 microgram per cubic meter per year. And organic compounds in PM 2.5, such as aliphatic chlorinated hydrocarbons, polycyclic aromatic hydrocarbons, PAHs, and nitro-PAHs, ketones, or quinones, may be an important part of PM 2.5 toxicity, according to Boji et al., 2015b. The water-soluble components of PM 2.5 are also very harmful to human health, according to Gautieri et al., 2009. And now let's see about the sulfur. Sulfur is a natural component in crude oil that is present in gasoline and diesel unless removed. Sulfur in gasoline impairs the effectiveness of emission control systems and contributes to air pollution. Reducing the sulfur content in gasoline enables advanced emission controls and reduces air pollution. In advanced countries, developed countries, we can have this treatment for eliminating the sulfur. But in the developing countries, usually the gasoline or diesel fuel contains this substance, sulfur. And now let's see about the NO2, atmospheric pollutant, one of the atmospheric pollutant. Usually, this is expelled by the automobiles, vehicles. And this NO2 plus sunlight hitting NO2, it will decompose to NO plus oxygen radical. And this O will join to oxygen in the atmosphere to form O3. This is the ozone. And here we have NO, and this ozone, O3, will join, and it will form NO2 plus oxygen. And this NO2 will join to another products in the atmosphere, and products such as PAN. This is very harmful to our eyes. And also this NO plus this R joining with OX, oxygen, maybe oxygen 2 or 3 or 4. So this will compose NO2 plus other harmful products. So this is the Zeldovich mechanism. The chemical reaction that leads to thermal NOx formation are N2 plus oxygen that changes to NO plus N, and this N plus oxygen will change to NO plus O. So in 1 and 2, in the first reaction, dinitrogen, this dinitrogen is attacked by oxygen to form NO and a nitrogen radical. So radical is very free, so it fluctuates freely in the atmosphere. So, and the nitrogen radical is free. So then attacks O2, the oxygen in the atmosphere, to form another NO and regenerates the oxygen radical, this. So, and this oxygen radical will attack N2 to form this NO plus N. So it is a chain reaction. So the overall reaction is given by N2 plus O2 to NO. So, and this NO here will join R or ROX to produce PAN, harmful substance, and NO2 plus other products. So that this NO2 in the atmospheric pollutant, this substance is very harmful to our health. Now, let's see about the formation of sulfuric acid. We had NO2, but this SO2 is another one. This is very harmful. And this is expelled directly from the industry or another sources. How to balance? SO2 plus O2 plus H2O to form this acid, sulfuric acid. This is a very strong acid and harms the human's skin or plantation forests, pollutes the lakes, swamps, and even the ocean. This is the reaction of sulfur forming acid rain. So 2 molecules of sulfur dioxide hit by the oxygen. It will form sulfur trioxide with 3 oxygens. And this sulfur trioxide here will join the water in the cloud of the sky to form sulfuric acid, H2SO4. So This is the reaction forming the acid rain. This is called acid, and this when it comes from the cloud, it is acid rain. So from these equations, you can understand that NO2 and SO2 are the pollutants of the atmosphere that creates the acid rain. So now let's see about the health effects of these pollutants. And fine particles can be easily inhaled in our lungs. So it will result in decreased lung function and also will create premature death. So the health effects of these pollutants are decreased lung function, asthma, poisoning, or toxic effect, increased risk of heart attack, irregular heartbeat, premature death, pneumoconiosis, that means dust in the lungs. So respiratory effect is very big by the atmospheric pollutants. Many particles can be trapped in our upper respiratory system and just mucus, nasal hairs, trachea. And however, some particles may reach deep into the respiratory system and become lodged in the lungs. This is the secondary health effects: reduced visibility, machinery falling, environmental damage, deposition, and aesthetic damage. Here is the map of the concentration of PM2.5 in the atmosphere, represented by micrograms per cubic meter. And as you can see here, this dark brown is hazardous, more than 5 until between 400 to 500 is hazardous. And in this area, 400 is very unhealthy, this color. Can you find this color here? And this red around 300 is unhealthy. Orange, unhealthy for sensible groups, for groups having asthma, for example, and respiratory problems. This yellow is moderate, and this green good, free from the PM2.5. So we can see that in India or northern India is very high. In China also. Here, China also, China. In India, maybe Nepal, Thailand also, Turkey. These countries have unhealthy to sensitive groups. This yellow is moderate. In Japan is moderate, and this green is free from the PM2.5, good. So in Mexico and in some areas, east areas of the United States and Canada, we have a moderate PM2.5. In South Africa, in Botswana, we have moderate, okay? And in Latin America, Brazil, We have moderate in Chile, moderate in Colombia and Honduras, this Central America, Mexico also. We have moderate to unhealthy for sensitive groups. If you'd like to take a look at this map is free and you can see anytime, hourly, daily, and monthly. This is of 2018, May 2nd. So now, what can we do to mediate this atmospheric pollution? Advocate for better air quality. Provide clean cooking and heating stoves to rural communities. Use cleaner burning fuels. Switch to clean diesel and improved engines for transport and freight. Don't openly burn waste. Prioritize the use of walking, cycling, or rapid urban transit over private vehicles. Ensure industries use clean technologies. This is the source from the UNEP, United Nations Environmental Program. And we have stricter vehicle emissions and efficiency standards, switch from kerosene lamps to clean light technologies like solar lights, establish, adhere to, and enforce air quality standards, invest in renewable energy, and stop emissions of climate pollutants such as black carbon, ozone, and methane to save lives and help reduce global warming by 0.5 centigrade, 0.5 degrees centigrade. Now let's see about the different countries. This is air pollution in China. Air pollution is responsible for about 2 million deaths in China per year. So this is a very big figure. Of those deaths, ambient air pollution alone causes more than 1 million deaths, while household air pollution from cooking with polluting fuels and technologies caused another 1 million deaths in the same period in China. Primary sources of pollutants include exhaust emission from Beijing's more than 5 million motor vehicles, coal burning in neighboring regions, dust storms from the earth, and local construction dust. Particularly severe smoke engulfed the city for weeks in early 2023, elevating public awareness to unprecedented levels and prompting the government to roll out emergency measures. This is the major Chinese cities' average PM 2.5. This is the amount for the annual limit by WHO. This source is the analysis of smart air filters comp. So this is the PM 2.5 microgram per cubic meter, 60, 0 to 60. So these are the cities with higher concentration of PM 2.5 in major Chinese cities. Zhengzhou, Xi'an, Tianjin, Beijing, Chengdu, Wuhan, Shenyang, Suzhou, Harbin, Hangzhou, Changsha, Chongqing, Shanghai, Guangzhou, Shenzhen. It is very difficult to pronunciate Chinese words. Many people thinks that Chinese is very similar to Japanese, but no, the grammar is completely different. And the words in characters we imported on the year 500 or 600 years, very old times. And the language is completely different. So we are using the characters. For example, mountain is a character like this. And the reading in China is sun, but in Chinese is a little bit different. But we imported both the Chinese pronunciation, and we already had the Japanese language. So we put to read writing we didn't have yet at that time. So we imported from China, and yama is Japanese word for sun. The same character, but different readings. So that's why once I was doing the lecture to a Chinese pupil, student, and she said that the pronunciation was very different. So what I read here is alphabet, so it's not Chinese, okay? I have to learn Chinese. Well, these are the PM2.5 pollution in major Chinese cities during 2014 to 2018. So this red is Beijing, blue is Xi'an, this is Chengdu, this is Changsha, and this is Shenyang, Shanghai, Guangzhou, and Shenzhen. And WHO annual limit is 10 micrograms per cubic meter. So all the cities are above this limit of the WHO. So this is the air quality in Beijing. Good. Shanghai, 65, moderate. Chengdu, 114, unhealthy for sensitive groups. And this is for ozone, PM10, PM2.5. This is at 8 o'clock, 7 o'clock, 8 o'clock. This is another cities, Guangzhou, Shenyang, and Hong Kong. Good here, and moderate, moderate. This is the average, okay? So if you'd like to see this in more details, you can check these sources for this site, HTTP. Okay. This is the sources of China's air pollution. Where does PM2.5 come from? Of the PM2.5 that comes locally from Beijing, vehicle emissions are the #1 source. So breakdown of Beijing's PM2.5 pollutants. Here, 24.5% is pollution from districts around Beijing. 22% direct and indirect vehicle emissions, 22%. And these are the burning coal to produce electricity, 16.7%, coal pollution. And this orange, factories, industrial emissions, 16.3%. And this is blowing dust from the urban fugitive dust pollution. And this is rural straw burning. Okay. So, effect of emissions in China and the implications. Power generation, ground transport, industrial, agriculture, residential, and commercial. These are the emissions, source of emissions. And this is the effect of these emissions. Air pollution, PM2.5, affecting the public health, 1.1 premature mortalities, and O3, ozone, crop production, harming the crop production by 20,035 gigagrams lost. So this is for economic cost, causes 267 billion yuan economic cost minus. Now, let's see about the other countries. This is still China. Sorry. But it is so dangerous to put the plastic bag. The boy might be suffocated by this, but he prefers, instead of inhaling this polluted air, to put the plastic. Vehicle fuel road integrated control system here in Beijing. The source is former Beijing Municipal Environmental Protection Bureau, Tsinghua University. Implement the China 5 for light-duty passenger cars and the China 5 for public fleets in February 2013. This is the measures of China for remediation. Implement the China 5 for freight trucks and long-distance coaches in June 2015. This is for the vehicle emission control, new vehicle control, in-use vehicle control, alternative fuel vehicles, better fuel quality, traffic measures, economic measures. This is a scrappage of older vehicles with subsidies. Scrappage all yellow labeled vehicles before 2016. And these measures: tightening the quota of new light-duty passenger cars, driving restrictions by stopping car driving 1 weekday per week, driving restrictions on light-duty passenger cars of China, half on weekday. And this is for greening. Promote CNG buses, promote electric buses and taxis. And this is the prohibition, enhanced 1-M program. Restrictive policies on use of motorcycles, heavy-duty trucks, and yellow labeled vehicles. So implement the China 5 fuel quality standards in June 2012. Implement the China 6-5 fuel quality standards in January 2017. But even so, during the corona crisis 2 years ago, the air quality of China was better because of the restricted economic activities because of the COVID-19. But now it is starting to worsen. But with these restrictions, it is not so bad as before. Now, let's go to Indian air pollution. The air pollution Map of India of 2019, November 4th. So as you can see here, the PM 2.5 air pollution concentration, you can understand by the colors that this color is very, very bad. This is hazardous, almost 500 micrograms per cubic meter. And this color is very unhealthy, between 300 to 400 micrograms per cubic meter. And this purple is between around 200 micrograms per cubic meter. And this red is unhealthy. And then this orange, unhealthy for sensitive group, and this yellow, moderate, and green, good. Here is Bangladesh. Around here is Nepal, I think, or not. Here is India, Nepal. But Nepal is also in this around 100 unhealthy. Okay. So air pollution in India, especially for the household air pollution, is very serious. Across the WHO Southeast Asia region, which includes India, an estimated 63% of all households are still exposed to unacceptable levels of pollution from the use of wood, animal dung, and crop waste for domestic cooking. This causes around 1.5 million deaths region-wide every year, each of which are 100% avoidable. So, by incentivizing the switch to cleaner energy sources, much of that burden can be rapidly lifted. The theme for World Environment Day 2019, Beat Air Pollution, one that is extremely pertinent for India. While air pollution is a global problem, the World Health Organization states that only 1 in 10 people on Earth breathe safe air. In India, the situation is rapidly worsening for both human and climate health. In 2017 alone, 1.24 million deaths, or 12.5% of the total deaths recorded that year, were attributed to air pollution. Of those, 480,000 died from household or indoor pollution. Average life expectancy in India in 2017 would have been higher by 1.7 years if air quality were at acceptable healthy levels. So people are killed by the air pollution. Well, here, this boy in India. In 2017 alone, 1.24 million deaths, or 12.5% of the total deaths recorded, were attributed to air pollution, as I said before. So this is before the COVID-19, but the boy is using already the mask. These are the sources of India's air pollution. Lead pollutants dissected. The sources of PM10 and PM2.5 vary substantially. This is the PM10 and this is PM2.5. Dust and construction. This is waste burning, transport, diesel generator, industries, domestic cooking. So this is for the PM 2.5. What's in your air in India? PM 2.5, tiniest, most unhealthy, high levels in winter because of the stoves. PM10, another lead pollutants on winter days, PM10. And ozone forms when oxides of nitrogen, NOx, react with volatile organic compounds in bright sunlight, lead pollutant in summers. So we can see here the size of this circle. The trucks are bigger, 14.2. And bus with clean energy, 1.6. Three-wheeler CNG, 0.3. Four-wheeler mixed fuel, 4.3. And two-wheeler petrol, 2.3. This is the measures to control air pollution in India. This is the Graded Response Action Plan, GRAP, that will come into effect in Delhi from October 15. Now it is into effect. EPCA has asked states to enforce moderate to poor measures, the rest to be adopted as per situation. This is a severe, very poor, moderate, satisfactory, and good measures. So immediate, moderate to poor steps. Impose heavy fines to stop garbage burning. Enforce pollution regulations in all industries. Stop flying of visibly polluting vehicles. Implement dust control norms, particularly at construction sites. Waterfly ash ponds every alternate day. So the measure is taken, and let's see how it is working. This poor, do periodic mechanized sweeping, enforce orders on diversion, cracker ban, deploy police at pre-identified vulnerable areas for smooth flow of traffic, use apps to inform people and register complaints. Very poor. If air quality turns very poor, stop use of diesel gensets, hike parking fees by 3 to 4 times, increase bus and metro services. Very poor. Stop use of coal firewood in hotels, RWAs to provide electric heaters to security staff to stop bonfires. Issue media alerts and advisories. Severe. When air quality enters severe zone, close hot mix plants, stone crushers, intensify public transport, increase sprinkling of water on roads and mechanize cleaning. Very severe. Air quality in severe plus zone. Stop entry of trucks into Delhi. No construction activities. Introduce odd-even scheme. Task force can take additional steps like shutting down schools. So each country are making efforts for different measures to control air pollution, but it not always it does work well, but they are trying to. This is a very poor invisibility in India because of the air pollution. Now, let's see about the air pollution in Mexico. According to the World Health Organization, WHO, Mexico City's air averages 179 milligrams per cubic meter of suspended particulates, well above the WHO 90 milligram maximum recommendation. Exhaust fumes from Mexico City's 3 million cars approximately are the main source of air pollutants. This is the Mexico City. Here, Mexico City, with fogs, very heavy fogs. Tijuana, Ensenada, La Paz, Hermosillo, Chihuahua, Monterrey, Guadalajara, Acapulco, Veracruz, Oaxaca, Tapachula, Cancun. From the color, you can understand that the most polluted cities are in Cancun, Veracruz to Oaxaca, and moderate between them. And good is in these areas. So now let's see about the sources of Mexico's air pollution. Key implications for health. Outdoor air pollution can have direct and sometimes severe consequences for health. Fine particles which penetrate deep into the respiratory tract subsequently increase mortality from respiratory infections, lung cancer, and cardiovascular disease. The 5 most populated cities for which there was air pollution data available had annual mean PM2.5 levels that were above the WHO guideline value of 10 microgram per cubic meter. This is the source of ambient air pollution database of WHO, May 2014. So all these big cities in Mexico have the above the WHO's limit. And outdoor air pollution exposure. Outdoor air pollution in cities in Mexico annual mean is, for example, this reached 35 micrograms per cubic meter, very high. This 25, this is 17 or 18, and this is 13. Guadalajara, León, Mexico City, Monterrey, Puebla. Now let's see about the sources of Mexico's air pollution. And air pollution in and around the home is largely a result of the burning of solid fuels, biomass or coal for cooking. Women and children are at a greater risk for disease from household air pollution. Consequently, household air pollution is responsible for a larger proportion of the total number of deaths from ischemic heart disease, stroke, lung cancer, and COPD in women compared to men. In Mexico, 20% of an estimated 3,800 child deaths due to acute lower respiratory infections is attributable to household air pollution, according to WHO. So, household air pollution in Mexico, the percentage of population primarily using solid fuels for cooking, the percentage in 2013. Rural areas, 50%. Urban areas, 6%. National total is 15%. And percent of total death from ischemic heart disease, stroke, lung cancer, chronic obstructive pulmonary disease, 18 years plus, and acute lower respiratory infections under 5 years attributable to household air pollution in 2012. The total death, 141,700. This, in orange, attributable to household air pollution is 10%. This is the whole total death. So the respiratory diseases is also very acute in Mexico. So we have the measures to control air pollution in Mexico. In 1992, Mexico signs the UNFCCC. 2000, Mexico ratified the Kyoto Protocol. In 2002, General Law for Sustainable Forest Development. 2012, General Law on Climate Change. 2015, Mexico committed to reduce emissions by 25% by 2030. So they are just beginning to lead for the measures. And now let's see about the air pollution in Bangladesh. According to the AQI score, source DOE PD 2019. Well, 0 to 50 is good. This is the PM2.5. This is the serial number 123 and city, name of the cities, and AQI data. In Dhaka, it was 264 microgram per cubic meter. Sabah, 180 microgram per cubic meter. It's so high. And Narayanganj, 268 micrograms per cubic meter. So these values range here in yellow. 51 to 100 is moderate. 101 to 150 is cautionary. 151 to 200 is unhealthy. 201 to 300 is very unhealthy. 300 to 500 is extremely unhealthy. So these values are here, unhealthy and very unhealthy. So this is the city of Dhaka in Bangladesh. So polluted. It's not good for our health at all. So we have three main sources of air pollution. Around 72% of national households use solid fuel, which contributes to air pollution according to State of Global Air 2019 in Bangladesh. The cause is brick kilns, fumes of vehicles, and dust from construction sites. This is the kilns, construction sites, fumes from the automobiles. This is in construction. So people that are walking directly to these places are heavily injured by the air pollution. So they will have, if they do not have the problem now, will have in the future respiratory injuries. So there are the enforcement limited to fines. Enforcement activities were almost halved last year in Bangladesh. The downward trend has continued over several years 358 mobile courts fined trucks of 10 city, shut down 120 brick kilns, sued 175 between December 2018 to April 2019. So this is last year, is in 2017. Enforcement of the law in 2017 and 2018. Drives against polluting vehicles, 61 to 35, decrease. Fines from polluting vehicles, TK 4.65 to TK 3.2. Cases filed against polluting vehicles, 279, decreased to 119. Drives against brick kilns, 279 to 324. And the air pollution sources, brick kilns, 58%. Dust from roads and surface, 18%. Vehicle emissions, 10%. Others, 149%. And these are the measures to reduce air pollution in Bangladesh. This is the strategy from A to Z. Improve public transport in large cities. B, strengthen vehicle inspection and maintenance, or especially large cities. C, ban vehicles older than 20 years, commercial vehicles, large cities. D, encourage diesel to CNG switch through incentives. All diesel vehicles, especially truck and buses in large cities. F. E. Emissions age-based annual registration fees, all vehicles. F. Stringent emissions standards, all new vehicles. G. Emissions-based import tariff, all new vehicles. H. Comprehensive land use plan for industry locations, all industries, especially new ones. I. Cluster management, cluster of highly polluting industries. J. Emissions technology and fuel-based license fee, all kilns. K. Technology standards, all kilns. L. Alternate construction material, all country, especially large cities. M. Ensure adequate power supply, all country. N. Emission standards, all new plants. O. Emission standard for diesel generators, all new generators. P. Inspection and maintenance of diesel generators, all existing generators. Q. Technology specification, existing steel mills, cement and glass factories. R. Inspection and maintenance for existing steel mills, cement and glass factories. S. Emissions standards, all new and existing plants. T. Import control for quality of coal, whole country, primarily brick and power industries. U. Better construction practices on site and during transport, all construction sites. V. Air pollution mitigation plan and its enforcement, large construction projects. W. Timely road maintenance, all roads. X. Landscaping and gardening, all exposed soil in urban areas. Y. Encourage fuel switch, urban slums and rural areas. Z. Improved cooking stoves, rural areas. So these are the strategy for measures to reduce air pollution in Bangladesh. So these are the reference for today's lecture. And these are very interesting and informative videos. So for the atmospheric pollution only. So if you have time, please watch them, and let's think about the remediating our atmosphere pollution. So thank you very much for watching. I hope that the war in Ukraine will end rapidly, and I hope that you all stay safe and healthy. Okay, thank you very much for watching, and bye for now. Let's see on my next lecture. Okay, so bye.